Rational or irrational? That is the question. Mr. Zonker here, and that was Shakespeare. I think he said something like that. And this video is going to be comparing and contrasting rational and irrational numbers. Let's get to it. So the short math definition of rational numbers is any number that can be written as a fraction. We have several subcategories. Integers are negative or positive whole numbers. Those can be fractions like if you put them over 1. We have normal fractions. This would be anything we'd normally write as a fraction already. Terminating decimals means the decimal ends, such as 1.5, 9.875. It stops. It doesn't keep going. Repeating decimals, that's when we have a decimal that goes on forever but repeats a pattern, such as 1.33333, etc., etc. Negative 2.454545, we see that pattern. And perfect square roots. That's a square root that we can evaluate to a whole number. Like square root of 4 is 2, square root of 25 is 5, negative square root of 36 is negative 6, etc., etc. Irrational numbers, on the other hand, is any number that cannot be written as a fraction. These are non-perfect square roots, like square root of 7, square root of 50, negative square root of 17. If you tried to put these in your calculator, you'd get a string of decimals that seem to be random. And that's why it's not a rational number. We have some special ones like pi, we know 3.14159265359, etc., etc. And some other special irrational numbers like e and a couple other ones that you might encounter one day. Outside of the vocabulary of irrational and rational numbers, I also want to take some time to look at how to convert repeating decimals to fraction. We said that repeating decimals that go on and on forever but have a pattern, we said they're rational, which means they can be written as a fraction. And it's all actually a pretty clever trick that we use to kind of use our math tools to kind of manipulate to find what that fraction would be. The steps are as follows. Set x equal to the decimal. Move the decimal so the repeating numbers are in front of the decimal point. Keep equality by multiplying x by the needed power of 10. Subtract an equivalent equation that removes the repeated decimal, and then solve. I have a feeling it's going to make more sense as we do a couple examples. So let's go ahead and do that. Example 1, we've got 0.3333 repeating. You might say, Mr. Zonker, I already know that's 1/3, and you'd be correct. But let's take this example we might know and see how we can apply those steps. So first we're going to say x equals our repeating decimal. X equals 0.333333. From there, we're going to move that decimal place until the repeating part is in front of the decimal point by 1 space. So we move that 1 space here, which means we need to keep balance. Ooh, ice cream. 1 sec. Choco taco. Sorry about that. The ice cream man waits for no one. Anyway, so we move that decimal 1 place to get the 3 in front. We multiplied by 10 to keep it balanced. And this is the clever part here. We can take that original or some form of that equation and subtract it. So if we subtract x equals 0.33333, we'll have 10x minus x, which gives us 9x. And then we've got 3.33 repeating, minus 0.33 repeating, and that repeating part will actually go away, giving us 9x equals 3. And if we solve for that by dividing by 9, we'll end up with x equals 3 over 9, or that 1/3 that we guessed that this would be. So that is the basic process. Let's try it out with one other example up here. We've got 1.0424242. Our repeating part is that 424242. So we'll keep an eye on that. First, we'll set x equal to the number. Then we want to move that decimal point until the repeating pattern gets in front. So that would be 1, 2, 3 spaces because the repeating pattern is 42. So I need 42 in front of the decimal. I moved it 3 places. So I need to balance it out by multiplying this side by 1,000. That's 3 spaces, 3 zeros. So I have 1,000x equals 1,042.42424242. Now we want to eliminate this decimal part, 0.424242. So what we're going to do is we're going to write the equation just so we have that repeating pattern after the decimal point. In this case, that would be 10.424242. Since we move the space 1 point to get that 10 in front, we'll multiply this by 10 and subtract the whole equation. We have 1000 minus 10x. That's going to give us 990x equals 1042.424242 minus 10.424242. The 0.424242 part is going to eliminate, leaving us with just 1042 minus 10, which is 1032. And then to solve this, we would just divide by that 990 and we'll get x equals 1032 divided by 990. And that's the fraction that will give us this repeating decimal. Just like we did to this 3/9, we can always simplify this, but when we have these crazy fractions anyway, I'm going to leave it just like that for now. And this fraction, we could always check by dividing in our calculators to make sure that we indeed do get that repeating decimal that we expected. All right, everyone. I hope this video was helpful.